Now we will try to solve a problem given in your textbook. You can see the diagram over here. And before solving such questions, first of all you will have to recall a few things like parallelogram law of addition of vectors. Suppose C is a resultant vector and A and B are the two arms of a parallelogram. Then you know this formula where theta is the angle between A and B sides of a parallelogram and C is the greater diagonal of that parallelogram. At the same time, for ready reference, one should understand that when theta is 0, then cos 0 is 1, and this will reduce to this. That means if the angle between A and B is 0, then C is nothing but the algebraic sum of A and B. Similarly, if A, B are acting in such a way that the angle between them is 180, that means they are acting just opposite to each other, then the mathematical explanation is cos 180 is minus 1. So a minus sign will come up over here because of this minus 1. And the entire expression will be A minus B. Now also you should keep this in your mind. If A has a greater magnitude compared to B, then the direction of C will be same as A. Once again I am repeating. If A is stronger than B or greater in magnitude, the direction of resultant C will be same as A. If this thing is very much clear, then again I will proceed to the next. Here the solved question has three charges Q1, Q2 and Q3 acting on the vertices of an equilateral triangle. You should make use of the data given. As it is an equilateral triangle, that means the sides are same and the angle will be 60 each. And we have to calculate the effect on a charge which is situated at the centroid. You can also recall the relation of centroid with the vertices. And the side is given as L. So each arm is having length L. Now we will solve the initials. I have redrawn the diagram. Let's say this one is L, and when a perpendicular is drawn in equilateral triangle, it will cut on the middle of arm BC. So this side BC, which is also L, then BD will be L by 2. Now this is a right angle triangle ABD, A, B and D. So applying the Pythagoras theorem, we can write AD square plus BD square equals to AB square. And AD can be calculated by putting the values of AB, which is L. So AB square becomes L square. And BD square, which is BD is L by 2, so BD square will be L square by 4. And AD has a square, so it will give a square root, and the expression will throw a value root 3 by 2 L. Now from the relation of centroid and the side, AO is 2/3 of AD. So again we can calculate AO. Now why we should calculate AO? because the charges are situated at the vertices, and the effect we have to see on the center. So the distance between AO, BO and CO is to be calculated. So AO, BO, CO is L by root 3. Now these are 30, then obviously this angle is 120. If we know these forces, then the angle between them is 120. Find the value of cos 120, which you all know. Then the resultant of these two vectors will act in this direction. And this resultant of these two have to be calculated against this one. So first we will see that whether this one is strong or this one is strong. If this one is strong, then the resultant will act of these two vectors. First we will calculate these two and we will find this, and then this will be calculated against this force. If this one is strong, then the resultant will act in this direction, that means O to A. If this one is strong, then the resultant will work from O to D. And if these two forces are same, then the resultant will be 0.